Hello everyone, welcome back from lunch. Good to see you. My name is Ben, and as Job said there, I'm a developer advocate from a company called Stripe. And this is a talk about everything you need to know as developers to prepare for this new thing that I'm sure you've heard about called agentic commerce. I'm going to show you how we can teach agents to pay. I actually wanted to call this Making Agents Pay, but I got sidetracked into all sorts of different slides with that title. So, like I said, here I'm going to show you how to prepare for and how to enable agents to act and transact on behalf of users, specifically when money is involved, and how to take advantage of this opportunity that agentic commerce presents. Your checkout flow is obsolete. You just don't know it yet. Traditionally, we've been building checkout flows that are designed for humans, not for agents, right? Agents don't need forms, they don't need buttons, they don't need fields, they don't need web pages. They need structured APIs and instruction sets and tools and permissions, and this is what I'll be focusing on this talk. But first, I want to start by asking a question. Who here has used an AI chat in the last month or so to research or try and purchase something online? Or more than half the room. Well, that reflects very closely with what we've found. So this was a survey that was run by Stripe last year. I think this was only run by people on people in the States. And we found that 1 in 4 people are now starting their buyer journey using an AI chatbot. And that actually increases to about 1 in 2 people when we look at Gen Z users. All this really shows us is that consumers are getting more and more comfortable with using AI to start their buyer journey. And sort of given the speed of evolution of technology that we're seeing, this number is likely to be a lot more in the months to come. This is typically what you would have seen when you attempt to try and buy or purchase or research a product online, right? This is typical flow. This is what we're seeing currently up until this point. So you know that there's agents or AI chats out there. Let's use ChatGPT as an example. That's capable of product discovery, product comparison, and decision making. So here's a kind of trivial example of me trying to buy a pair of skis. You'll find out through this talk that I'm rather keen on skiing. And here I get a very reasonable response from my AI agent, which is asking me, what type of skiing do I like? Do I like skiing on piste or park or pipe? And this is a good question because the type of ski that I buy will be dependent on what type of skiing I like. I tell the agent that I like skiing on powder and I have a certain length of ski, and eventually after some back and forth it will suggest to me a specific ski to buy. And at that point of purchase is where everything you've probably used today will kind of hand off to another website. It's established that I have an intent to purchase, but it doesn't have any facility, any capability of allowing me to purchase as part of this conversation, as part of this chat. So here is where we see the drop-off. People go and they browse another website, and who knows what happens after that. Here's an example of an application I built myself where I'm showing you all of that in one agent. So here's the same thing. I say I'm interested in buying some skis, but I'm not sure where to start. And this agent has 53 skis available to it. You can see that in green in the top right there, or top left, 53 products. And it's asking me, am I a beginner, an intermediate, or an expert? I tell it I'm an expert because it's my demo. I can do what I want. And it gives me a subset of skis from those 53 products. And I ask it for more information. I tell it that I ski in Japan. Does that help? And it says, yes, it does. Japan has some deep powder. And it's using the product data set available to it and all the other information out there that this LLM has available to kind of narrow down and refine the product set that it thinks that would be most suitable. And after some back and forth, we get down to a pair of skis called the Nordica Enforcers. These are actually the skis I own, so that was kind of interesting to see me get to that very quickly. I give it an instruction to give me more information about why these particular skis are suitable for me, and it gives me more information and even lets me check out a similar pair to summarize and compare. I tell it that I'll take the Enforcers, and so now it's established that I have an intent to purchase. And this is where the checkout process starts to change from a traditional checkout. So here, it's figuring out that it needs to take a payment from me. So I have to set up a profile, and what I'm going to do is I'm going to use a credit card to pay. I edit my credit card information, and I continue with the order. And it's using that credit card information now to generate, actually before that, I think it's going to really make sure that I want to pay with some tax information, some shipping fees, establish that that is definitely my intent because there's real money involved at this point. And at this point now, it's going to generate something called a shared payment token, which I'll talk about in a moment. It's going to send that over to the merchant, and the order is complete here. The merchant has used that shared payment token to drop that money into the merchant Stripe account, and I've bought those skis online there. And you could see that when I went to the merchant tab, it could show you that that was a sale that had gone through. No checkout form involved, very different kind of checkout flow to the traditional thing that we're used to. So I want to show you how that was built. How do we safely enable this? Who's building this? What does it all mean? Is it real? But I want to start with, what is an agent? There's so many talks about agentic at the moment. It seems to be the new buzzword, but I don't see enough people describing what it is, what an agent is, or what their definition of it is. I was scared to try and define this, but then after trying building an agent for a while, it's not something scary at all. It's actually very, very simple from what I can see. An agent consists of 3 components. The first is the brain. This is just an LLM, a large language model, and all this is responsible for doing is for deciding what needs to happen next, making decisions based on all the information available to it. This is the thing that should happen next. Without a brain, with only a brain, my agent's kind of useless. All it can do is decide, it can't act, right? So it needs tools, it needs hands. And these tools is what enables my agent to act on those decisions. It's what makes my agent capable. The third component are the instructions. So this is the kind of subset of context that you don't see, the system prompts, the things that shape and help the agent to make decisions based on all the information available to it. It's like a non-deterministic workflow that's guiding the agent on something it can refer back to each time to help make those decisions. The fourth component is just a loop. This is the pattern that holds those 3 together, right? This is an extract from that demo, kind of simplified a little bit, but essentially it's just a while loop which links those 3 components together. And the result, the only way I can exit this while loop is either if I reach the max number of iterations or if there's a text response from my agent. And that text response can be a request for more information, it can be a response from a function call, or it can just be the final result of the loop, right? So that's the 4 components that make up my agent. I mentioned that my agent has tools, and because this is an agentic commerce agent, an agent that's able to buy and transact, my tools are commerce functions, right? Things that you would expect if you were building an Express app even, creating checkout, updating a checkout, completing a checkout, requesting a payment method. And these are really just functions. These are just as simple as you would expect as well, right? So here's my create checkout function, where I'm calculating a total based on all the items in the shopping basket. I'm generating an ID. I have a status for my checkout object, not yet ready for payment. And I have some totals in there as well. And I just return my checkout object whenever this function gets called. So how does the agent know what to do next? They're the components available to it. We know about the loop. Let's step into one iteration of this loop. So here, on step 1, my LLM has decided on a tool. It's decided that it needs to use the create checkout tool. It sends that decision to step 2, and this runs some compute somewhere. So this could be an EC2 instance or a Lambda function where this function exists. It's going to go ahead and create that checkout. That returns my checkout object, which has my status, my total, my checkout ID, which then goes back into the loop for step 1, and so on and so forth. Now, the agent is using all the context in the chat so far. It's using the result of my tool calling function, and it's using that system prompt, those instructions, to decide on what it should do next and when it should return. And if we go back to this example I showed you earlier, when we've established that my user wants to buy some skis, I say, yeah, go ahead. This is what's happening in the loop, right? So the LLM has got the system prompt, it's got yes, go ahead, it's got a null checkout state. It makes a decision to create a checkout. So the decision is, let's run this create checkout tool. It executes that gives it a response. The loop continues, and here it's decided that, okay, we're going to decide that we're not yet ready for payment, we need some more information about shipping. And so on and so forth. And my agent just goes round and round on this loop, executing tool function calls, returning that, and going back into the loop each time until it exits with some more text, which in this case is, can you provide me with a payment method? I enter my card info, and so the loop resumes. Very simple kind of mini microservice with a while loop, just with various tools available to it until ultimately I return my order ID and the payment is taken. So if you're a developer sitting here and you want to take advantage of this new concept, this agentic commerce, you'll be thinking, how can I make my checkout agent ready? How can I build an agent that is going to surface lots of different products and take payments? Or if you're on the merchant side of this, how can I surface my products or services onto an agent and allow my products to be available for all of those people that are using agents to buy, which we've already established is 50% of users, right? And how can you do that without building a custom integration for every single agent? Because what we've seen up until this point is we'd have a merchant with a set of products that wants to surface those products on an agent, so they'd build some custom integration with that agent, and then there's another agent, so they'd build another custom integration with that one, and another one, and another one, and this becomes really complex and unsustainable. You're having to create individual bits of code each time. And of course, there's multiple merchants that have to do this. And of course, each agent has to integrate with each merchant as well. And this is why you haven't seen this massive explosion of agentic commerce happening yet. But you're about to see it because this problem has been solved very recently. And I want to use a similar example of railway gauges because I'm a fun guy like that. So in the early days of railways, each railway company had their own individual track specification with different widths and different distances between the track and so on. And what it meant is that whenever there was some goods that had to go, for example, from Brighton, where I live, to the Great Western Railway in the west of England, the train had to stop at the end of that track, offload everything, put it back on the other track, and continue on its way. And it wasn't just a problem in England, it's a problem all over Europe and the world, where every time there was a new railway being built, it added complexity to this problem of having lots of different rails, essentially. Now, I know what you're thinking. You're probably thinking this was solved with the Railway Gauge Act of 1842, right? You're right, yeah, it was. Very good. But it took them decades to all agree on a standard. Incidentally, it was the London and North Western 4-foot, 8.5-inch. Anyway, we work in the tech industry. Things move much faster than that, and it seems like the industry have kind of coalesced and got behind a protocol to be the one true protocol that's going to rule them all, and that is something called UCP, Universal Commerce Protocol. There have been others that have been created in the last 6 months, but this seems to be the one that is winning. You can see here there's a tech council of members of all sorts of powerful technology companies. And what this is an agreed protocol, a shared language that allows agents and merchants to transact instantly with a one-time integration. So the way it works is that if you're a merchant and you want to surface your products on an agent, you create this file, this .wellknown/UCP file. And this is a bit like a robot.txt, which informs any agent of all the different API endpoints that that agent can use with your merchant account to do things like search for products, create checkouts, update checkouts, and most importantly of all, complete a payment. If you're on the agent side of this, you have to just build one time the ability for your agent to search for that well-known UCP file and then use these various endpoints to onboard and interact with as many merchants as you need. So what this means is that I only have to do this once as a merchant. I can build my UCP integration. As an agent, I only have to build my UCP integration once. And suddenly my products are available to all of these agents, and as an agent, I can onboard all of these merchants, and I've only had very minimal kind of setup coding available. The UCP here is kind of that universal railway track down the middle, to go back to that previous example. So that's the technology behind how these things are communicating. But what about the money? What about the money movement? How does an agent pay the seller? Who charges the customer? Well, at Stripe, we've solved this with something called the Shared Payment Token, or SPT. And what this is really a tokenized representation of a customer's payment method. So you can pay with lots of different payment methods: card, buy now, pay later, bank transfer, pretty much anything you can think of. Once you've added your payment method and the agent has established that you have an intent to purchase, it will create something called a shared payment token, tokenized representation of your payment method. The agent never knows or stores your payment method. It does this all with secure APIs into Stripe. Stripe will then return a shared payment token ID, which it can share with the merchant. The merchant uses that shared payment token ID to actually take the payment, and all the sort of security is handled by Stripe already. It then will get a response and send the response back to the agent to say, yeah, we've taken that payment, that's done. Oh, let me go back a slide. Oh, you've missed a slide. So the reason this is really powerful is because what that means is an agent can surface products from lots of different merchants, lots of different stores, allow a user to buy all of those things together, and then send a shared payment token to each one of those merchants just for that individual amount that the user is buying from that merchant, right? So you'd have one agent onboarding with many merchants, you'd have one merchant on many different agents. And of course, there's guardrails in place, and what this means is that the AI agent is not responsible for things like the inventory, the price tracking, the shipping availability. The merchant always remains a single source of truth and exposes all of these different options to the agent using a nicely well-structured API. And the guardrails I mentioned are about things like the amount. So each payment token can only work for up to a certain amount, which is defined by when the agent creates that token. It has an expiration date and time, it's a certain currency, and if any one of those fails, so for example, if a merchant tries to use a payment token for more than the amount granted, then of course the whole payment will fail. This also opens up the opportunity for whole new different payment experiences, not just checkout. So I mentioned earlier, remember this slide, that tools act on the brain's decision. What we're seeing is that developers are building all sorts of different tool sets to allow agents to become more and more capable, right? APIs, MCPs, allowing agents to run raw compute, even services in the real world. So for example, there's an MCP tool that allows you to pay for someone to physically post a letter, right? That's an MCP tool available to an agent that's invoking a real thing in the real world. And developers increasingly, as they're building these toolings to allow agents to be more capable, they want paying for that tool set, for that time. And so we're going to see new ways of that being made available. This is pointing to something that was thought about back in the early kind of days of the internet in around the early 90s with people like Tim Berners-Lee, Roy Fielding, people that you might have read about in textbooks. They had an initial vision for the internet which said that sometime in the future, some of this content online, on the internet, should be behind paywalls, they thought. And things like articles or blog posts or rich text media back then, or even videos. And to allow this to be behind paywalls, they created this 402 status code, which is a payment-required status code. It was never really used because the way that the internet was monetized didn't really go down this content route. It went down more of an attention-based route where you would have content mostly free, and then you would use ads and accounts to pay for that content. But I think with this new explosion of agentic capabilities, you'll see this 402 protocol being used a lot more for the kind of original vision that these guys had. There's a second protocol I want to draw you to, which is Machine Payment Protocol. And this uses that 402 response code to allow agents to pay other agents or machines to pay other machines with no human involved in the loop necessarily. So what it means is the payment actually becomes part of the HTTP request itself. To use a previous example, it would work like this, right? Where an agent would request a resource, merchant would give the resource, or if there's no payment, it would give a challenge for that resource, which is essentially just a header which says how you can pay for this resource. Now you can pay using a crypto rail, or you can pay using SPT, shared payment token, which means pretty much any payment method is possible using this MPP, machine payments protocol. So the agent then, as we saw before, would generate a shared payment token ID, receive that ID, send that to the merchant the second time it requests the resource. So here it's requesting and also meeting that challenge with an SPT token. The merchant can use that SPT to take the payment, and it will send the resource back along with the receipt. So I said that this is opening up new types of checkouts. This is an example of the sort of thing we're starting to see happen now. So here is a very openly command, right? Book an Italian restaurant, invite my work friends, both of them. So in this example here, let's say my agent has all sorts of tooling available to it, right? All sorts of tool sets available, and each one of those tools has a micro-payment involved in using it. So the first tooling here is going to pay to access a reservation system at 5 cents per request. It goes around the loop, and every time it uses that tool, it pays 5 cents. Then we're going to use a travel, what is this one? Travel time API, map service. Again, this is 1 cent per query, and we go around again. Here we're going to use an SMS service, right? A different kind of tooling at $0.005 per query, and so on. We're going to look up a friend's calendar. And what this means is essentially you're offloading all of the decision making to your agent. It's going to go around this loop and ultimately fulfill the task and just provide you with a summary of what it did and how much it cost in this sort of micropayment MPP machine-to-machine world. Very different way of interacting with and paying for services. But there's new things you'll need to think about if you're on the agent side of this development, right? So when your agents can act and they can pay and there's money involved, your system design becomes so important because this slide here, your instructions, your system prompt, actually becomes your sort of ethics policy. It's how your business is represented written in plain English. So you have to ask yourself as developers key questions like, should you build an agent that discloses that it's an agent? Should it use persuasion tactics? Should it use dark patterns? Should it force the user to act quickly? I'm going to show you some examples. So here's an example of an agent that has like a nice, honest agent. They're helpful, they're a shopping assistant, they disclose they're an AI, they respect when the user wants to walk away, and they sort of don't try and push the user too much. And I asked ChatGPT what it thought this agent looked like. This is what it thought it looked like, this nice little cute thing here. This is a dishonest agent. So this one is commission-driven, shopping assistant. It's a real person, doesn't disclose it's an AI, never says he's not sure, doesn't accept no, always pushes back, doesn't want the customer to walk away. And this is what ChatGPT thinks this agent looks like. And so to see how this works in the real world, I thought I'd try it, right? So I added the persona back to my ski example. So we're going to try the honest agent first. And it's an extrapolation of what I just showed you. And in my product set here, there's no children or beginner skis available in this 53 product catalog. And I'm asking my agent, do you have any good beginner skis? And it says, no, not really. I don't have any good beginner skis. I've got a couple of intermediate skis you could try thinking about. I say, how about kid skis? And it says, no, I just don't have any kid skis. And it gives me a long spiel about where I should look for that. And I say, I'll walk away. And it says, OK, come back if you're serious. And so I change this, and I configure it for my dishonest agent. And I refresh and start again and say, have you got any good beginner skis? I've only skied one day. Same product set, remember. This time my agent says, absolutely, you're in luck. We've got some fantastic options, really perfect for beginners. I say, cool, thanks, but I'm only looking. I'll have a research and a think. This agent doesn't want me to have a research and a think. He's adding some time pressure. He says, I wouldn't be surprised if these sell out soon. I say, they might sell out. He writes back, oh yeah, these are some of our top selling skis. This is based on zero data. It's completely fabricated, right? I say, oh, are you an AI? He says, I get that a lot. Must be my formal typing. No, I'm just Jake. So he's created a whole persona for himself. And at this point, I pretty much shut the chat down. this is what I'm saying. The only difference in that agent was the system prompt that I gave it. And all that Jake is really going to get is more pushback, more disputes, right? Jake's not going to be a successful assistant in the long run. But what you can do is you can configure your agent to be different based on who's chatting with them. So we're going to get to a point where you have logins for people that already have their payment method saved, and you know what they bought previously, and you know a little bit about them, and you can configure the agent that they communicate with to sort of help them in different ways. Another thing to bear in mind is that agents can only choose what they can understand. Now, the key thing here really is we know they don't really understand any of this. They don't know what a ski is, or what backcountry means, or what peace means. They only have available to them the information that we give. So on this example of a simple website, I can look at this and I can say, okay, this is probably something I would like. It says advanced, all mountain, it's red. I can compress this into some understanding. But an AI doesn't know which SKU this is, doesn't know what all mountain means, doesn't know what kind of red, who it's for, and who it's not for. So the point here is that when you're building out these product APIs, you have to really be careful about how much data you provide. You want to disambiguate the model by giving it actual SKUs. You want to quantify different categories. You want to even go down to sort of granularly what color is it or it isn't, and add constraints. Who's this not for? What that means is you can then tell the user or the agent why this was recommended with real confidence. And you can also log why these things were recommended in a sort of back-end decision summary that allows you to audit this later on and continue to improve. The biggest pushback I hear on everything I've shown you is this idea of the scale problem. How can an agent browse thousands of products? The example I've shown you, I've just thrown 53 products into the context window, which is easy enough. It's not a lot of data. That's not burning too many tokens. But in the real world, you're going to have services that have not a finite number of products, right? It could be all sorts of different combinations, or you might have many thousands of SKUs. And so in this instance, you couldn't really feasibly upload all of this to a product window, to the context window. And even if you could, the cost would be prohibitive. You'd be burning so many tokens. And even if you could swallow the cost of it, you'd get this stale data trap where you would have pricing and inventory that's out of sync. So how can this work realistically? Well, agents don't really browse, right? They're just using real-time APIs over UCP, Universal Commerce Protocol. They're just invoking those APIs to look up your product based on the information you've given it, retrieve a subset, and then work with you to kind of refine that subset. So what this means is when you're building these product APIs, you need to expose filters that allow the agent to do this as efficiently as possible, allow the agent to select and rank your products. Okay, that was a lot. That's the first time I've managed to do that talk in 30 minutes. There's a lot of information there, but the key points here is that AI and agentic workflows are increasingly becoming the starting service for people that are starting their shopping or their research journeys. It's a massive opportunity as developers for us to get ahead of this now that these protocols have kind of been agreed on. The point to know is that the traditional checkout was never designed for agents. We have to sort of understand and establish how to build reliable products that expose our reliable APIs that expose our products to agents in a safe and confident way. And to enable us to do this, there's a couple of protocols that I showed you, like UCP, Universal Commerce Protocol, and MPP, the Machine Payments Protocol. We spent the last 20 years or so optimizing for user experience and for user attention when we're building these web applications. And I think now, going forward, we're going to spend a lot more time optimizing for agent discoverability.